Hello again, fellow stats enthusiasts, and welcome. Welcome to those joining us for the first time. If you are joining us for the first time, I'd like to suggest that you first watch the first two screencasts I made, which which discusses what stats is and what data is. It's up to you. Just a reminder for those that are joining us for the second or the third time that my name is Bronwyn and I'm a lecturer at DICE, Department of Industrial and Systems Engineering at CPUT, and these screencasts are part of an open education resources project. So please watch it as many times as you need to, download it and share it, and tell your friends about it, and tell them about the project that we have at CPUT. So the last time when we finished, we looked at what data is. And so now that we have an idea of what data is, we can decide how we're going to go about analyzing the data. To start off, I'll say that the human brain is much better at processing images than what it is at processing long lists of numbers or of words. And so we can actually just look at this table and the schematic to give us an idea. But both the table and the schematic are saying the same thing, but the picture is communicating information way faster than what the table is. And this is a form of descriptive stats. Both of these are a form of descriptive stats, and that are discussed in screencast 1, or mentioned in screencast 1. So what we're going to discuss next in the next following screencast are some very basic descriptive stats techniques, and these are pie charts and the leaf stem plot, which I'll discuss in this screencast, but the screencasts are only 15 minutes long. So after that, in screencast number 4, I'll discuss a scatter plot, a time series chart, and quartiles, and a box and whisker plot. So getting back to how we convert data into a simpler, easier to communicate form, we start off with the table. We got the raw data and we organize the data into a table as we would see here. Now let's say this table is of favorite colors of everyone at CPUT, or not everyone at CPUT, of a sample at CPUT. And as you can see, 43,500 people said they like light blue, 12,200 people said they like orange, etc., etc., etc. What's important here is the total number in our sample. The total number in our sample is 75,000, and let's just write that down. N is the total number of the sample, 75,200 people. And that's important because the next thing that we have to do is we have to convert that into a relative frequency. Now, relative frequency is a form of percentage. Well, it's one step prior to working out your percentage. And I'm assuming most of the audience are students, so I know you're experts at working out percentage, having to work out your marks and all. But humor me. So to work out the percentage, we take the proportion of each of the categories that we've selected or that we've sampled, and we divide that by the total sample size. And to work at the percentage, you would then go one step further, but if we do that I've just mentioned, we will obtain the relative frequency. And to work at the percentage, you'd go times 100%. But this relative frequency is important for us when we want to construct a pie. Once we have the relative frequency for each of these categories that we sampled, it's a good idea to do a control, a quality control. You see, all of the relative frequencies, the sum of all of the relative frequencies should add up to 1. And similarly, if you work that out to percentage, then the sum of all of these should add up to 100. Now, the next thing we know is that a circle consists of 360 degrees in total. So now we've got to work out what portion of this entire circle, this entire thing represents 360 degrees. What portion of that 360 degrees can we assign to each of these categories? And to do that, we take that relative frequency and we times that by 360. So if we take 0.578 and we times that by 360, we have an answer of 208.2 degrees of the circle belongs to light blue. Similarly, 0.162 times 360 will mean that 58.4 degrees belongs to orange. And we do that for all of our different categories. And so now we know what slice or what proportion of the pie, how big the slices are for each of these categories. The next thing that you do is you actually draw your circle. And based on the information that we worked out previously, we will use a compass and we'll actually draw out, or we'll allocate the proportion to each of the categories. So light blue was 208 degrees. So this section is 208.2 degrees of the 360 degree circle. Orange was 58.4 degrees of the 360 degree circle. And it doesn't matter where you start. I like starting on top here, but you can start on the side if you want to. You could start on that side or even at the bottom, anywhere in the circle, as long as you accurately capture the size according to the calculation that we did in the previous slide. So that is a pie chart, and it's a great form of descriptive statistics. A picture paints 1,000 words. That's what is said. And a pie chart does the same thing. Okay, so going on to the next one, we have a leaf stem plot. And a leaf stem plot is another great way to quickly communicate data by organizing it in a way that will make sense to the human eye if you just look at it quickly. Now, when I look at this data set, there's 30 people in this data set. And how this works is, looking at the key here, we'll organize it in categories. And the categories here is everyone less than 10, everyone in their teens, everyone in their 20s, everyone in their 30s, everyone in their 40s, and everyone in their 50s. Well, you can see that there's only one person in their 50s. But this data shows the ages of the people that stay in my road. And the thing is that's important to remember is these numbers on the left side of this line are not data points. These numbers on the left side of the line are actually the categories. However, these numbers on the right side of the line represents my 30 people in the sample. And so here we'll find that there's a 6-year-old, a 7-year-old, and an 8-year-old. Here we'll find that there's someone that's 10, someone that's 12, 13, 14, etc., etc., etc. So now I have a question. The question is, what kind of data does this represent? And if you don't know, you'll have to refer back to screencast number 2 to see what it is. Any takers? This is actually ratio data. Because as explained in screencast 2, feel free to go refer back to that if you need to, it is data that can be multiplied, it can be added and subtracted. And then I have another question as well. How many people stay in the road? Now, I mentioned this earlier, but you can work out how many people stayed in the road by checking out the leaves. You see, this over here, the categories, that is known as the stem, and these are leaves on the stem. And if we were to count each of these observations in the leaves, we'd find that our sample size is 30. But as I mentioned, I have mentioned that the sample size is 30 previously. We'll also be able to, using the leaf and stem plot, we'll be able to answer other questions about our data, such as how many people are younger than 15 years old, or for that matter, it could be any number, how many people are older than 40 years old. And because this data shows us, where's the cut-off line? There's a 14-year-old and there's a 17-year-old. So 1, 2, 3, 4, 5, 6, 7 people are younger than 15 years old. But we can do that for any of the values that we select or that is of interest to us. And finally, we can also work out what the highest frequency is. So what's the highest frequency if we have a look at this leaf stem? Of course, it's the teens. So it is this group here. That is the highest frequency. So as we can see, the leaf stem plot really is a very, very, very useful tool that we can have in our stats toolbox. And I really like the leaf stem plot because it allows us to not only see the actual data points, and later this will become more important, it allows us to see the shape of our distribution. And that's now something I'm not going to go into detail yet, but at the end of the set of screencasts, you'll have a better understanding of why the shape of a distribution is very important. So that brings us to the end of the third screencast. Thank you so much for joining me again. I hope you're going to join me for the next screencast, and I'll see you in a bit.